Welcome back. We're about to do lesson 2.2, talking about conditional statements. Conditional statements have like if-then format. And this bumper sticker company had some misprints. Instead of if you can read this, then you're too close, some of them said if you are too close, then you can read this. Some of them said if you cannot read this, then you are not too close. And some of them said, if you are not too close, then you cannot read this. So, can we figure out which ones are true and which ones are false? That's kind of what this lesson's about. So what's a conditional statement? It's an if-then statement. We got a hypothesis, so it's if the hypothesis, then the conclusion. Sometimes we use these symbols, P for the hypothesis and Q for the conclusion. So then we can write P implies Q, or if P then Q. And then if you wanted to draw like a Venn diagram type thing, this would be interpreted as if something is P, then it's definitely already inside Q. So if something's P, then it's already Q. P implies Q. If P, then Q. Alright, so the first kind of thing we're going to do is identifying the hypothesis and conclusion of a conditional statement. If an animal is a robin, then the animal is a bird. So the hypothesis goes right after the if. So hypothesis P, the animal is a robin. The conclusion is after the then. So the conclusion is Q, the animal is a bird. So what are the hypothesis and conclusion of this conditional? Well, the hypothesis is an angle measures 130 degrees. The conclusion is that angle is obtuse. How can you write the following statement as a conditional? Vertical angles share a vertex. See, that's not an if-then format, is it? But we need to identify the hypothesis and the conclusion. Vertical angles share a vertex. So, if angles are vertical, if two angles are vertical, then they share a vertex. So, see if you can write dolphins are mammals as a conditional. Okay, so my hypothesis is that there's an animal that's a dolphin, and my conclusion is that it's a mammal. So I would say, if an animal is a dolphin, then it is a mammal. The secret phrase for today is the name of a game that my son made up when he was 2 years old. It's called Hoopy and Doobers. Alright, is this conditional true or false? So we're going to talk about finding truth values of conditional statements. Here's our conditional. If a woman is Hungarian, then she is European. If you don't know anything about Europe, then this one's going to be difficult for you. You might have to use Google. But this one is true. Hungary is a European nation. So Hungarians are Europeans. So this conditional is true. That's its truth value. True. Ha-ha! If a number is divisible by 3, then it is odd. Let's see, is that true or false? Well, I can think of a few numbers that are even that are divisible by 3. Like 3 times 2 is 6. 3 times 4 is 12. There's a couple that are divisible by 3 but are not odd. So this conditional is false. In order to say that a conditional is false, you have to provide a counterexample. So here's a counterexample. We say it's false, 12 is divisible by 3, but is not odd. Alright, so check on 3. See if you can decide whether each conditional is true or false. If it's false, see if you can find a counterexample. So what did you think about A? If a month has 28 days, then it is February. Well, it doesn't say that it has exactly 20 days, it just says it has 20 days. So we can say that this is false, and we can say that January has 28 days plus a few more, right? Right? Every month has 28 days in it at least. So that one is false. If two angles form a linear pair, then they are supplementary. Well, that's pretty much the definition of supplementary. Two angles forming a linear pair means they add up to 180 degrees. So that means they're supplementary. So that one is true. You'll notice I said the word definition. That might come in handy next lesson. Okay, so we're going to talk about what is the negation of a statement. It's the opposite of a statement. So if we got a statement that says the sky is blue, the negation would be the sky is not blue. So if we have a statement P, we can write the symbol for the negation of P using either this tilde, or sometimes you'll see something like that, not P. But I like the little tilde P if you're writing it. And also there's one on your keyboard right above the tab button. So we can use negations to write statements that are related to the conditional, kind of like those bumper stickers at the beginning. So every conditional has 3 related conditional statements. So the conditional, you use the given hypothesis and conclusion. So here's an example. If the measure of angle A is 15 degrees, then angle A is acute. The symbol for that is P implies Q. Or you can say P implies Q, or you can say if P, then Q. The converse of a statement switches the hypothesis and the conclusion. So that would be like this. If angle A is acute, then the measure of angle A equals 15 degrees. So that's not always true, but that's what the converse is for that statement. Symbolically, we would say Q implies P. We'd say that the conclusion implies the hypothesis. So if Q, then P. The inverse of the statement is you negate both the hypothesis and the conclusion. So if the measure of angle A does not equal 15 degrees, then angle A is not acute. We would say not P implies not Q, or if not P, then not Q. The contrapositive, which was going to be my rapper name if I ever became a rapper, says you negate both the hypothesis and the conclusion of the converse. So the converse switched the order. The contrapositive switches the order and negates both of them. So if the measure of angle A, or no, if angle A is not acute, then the measure of angle A is not 15 degrees. Not Q implies not P. If not Q, then not P. So let's take a look at these statements and then talk about their truth values. So the original conditional statement that we had was, if the measure of angle A is 15 degrees, then angle A is acute. Is that true or false? Well, acute angles are defined as angles that are between 0 and 90 degrees. So if the measure of angle A is 15, then it's definitely acute. So that is true. How about the converse of that statement? If angle A is acute, then the measure of angle A equals 15. So is that always true? If you have an acute angle, is the measure of that angle always 15 degrees? No, it could be 16 degrees, it could be 1 degree, it could be 89.7 degrees. There's a lot of different measurements that an acute angle can have other than just 15 degrees. So that statement is false. And we could have a counterexample saying, how about measure of angle A equals 20 degrees? There's an acute angle that's not 15 degrees. How about the inverse? If the measure of angle A is not 15 degrees, then angle A is not acute. Well, I can think of a counterexample to that one too. How about measure of angle A is 20 degrees? The measure of angle A would not be 15 degrees, but it would still be an acute angle. So that one is false. How about the contrapositive? If angle A is not acute, then the measure of angle A is not 15. So if the angle is not acute, that means that if the measurement is either 90 or more, right? From 90 up to 180. That means that it can't be 15 degrees. So this one's also true. You notice that these are kind of color-coded. And conditional statements have what we call logical equivalence. The original conditional and its contrapositive are equivalent statements. That means they're either both true or they're both false. The converse and the inverse are also equivalent statements. That means that if one of them is false, the other one's false too. If converse is true, then the inverse is also true. Alright, so what are the converse, inverse, and contrapositive of the following conditional? What are the truth values of each? If the statement is false, give a counterexample. If the figure is a square, then the figure is a quadrilateral. Alright, so what are the hypothesis and conclusion? The hypothesis is the figure is a square. Conclusion is the figure is a quadrilateral. So the converse is if Q, then P. So the converse would be if the figure is a quadrilateral, then the figure is a square. That is false. Because here's a counterexample. Here's a rectangle. It's a quadrilateral, but it's not a square. What about the original statement? Was that true or false? If the figure is a square, then the figure is a quadrilateral. That one is true. Because a square has 4 right angles and 4 sides of equal length. So that definitely qualifies as a quadrilateral. Quadrilateral just means it has 4 sides. Okay, so after the converse, we can do the inverse. The inverse is just the negation of the hypothesis and the conditional in the original order. So not P implies not Q. That means if a figure is not a square, then it is not a quadrilateral. Is that true or false? Well, that's also false. Here are some examples. A rectangle, that's not a square, but it is a quadrilateral. This guy right here, it's just an irregular quadrilateral. It's not a square, but it is a quadrilateral. And this parallelogram is not a square, but it is a quadrilateral because it has 4 sides. How about the contrapositive? The contrapositive switches the original order and negates them. So not Q implies not P. So in this situation, it would mean if a figure is not a quadrilateral, then it is not a square. And that is true. If a figure is not a quadrilateral, that means it doesn't have 4 sides. And if a figure doesn't have 4 sides, there's no way it could be a square. So that's true. So we can see that our logical equivalence worked out. The contrapositive is the same truth value as the original statement, and the inverse and the converse have the same truth value. They're both false. So what are the converse, inverse, and contrapositive of the conditional statement below? And what are the truth values of each? If a statement is false, give a counterexample. Here's our original statement. If a vegetable is a carrot, then it contains beta-carotene. Okay, I'm going to make this little chart show up here. And you might want to have this kind of a little chart in your notes to help you remember what's the converse, what's the inverse, what's the contrapositive. Alright, so the original conditional is, if a vegetable is a carrot, then it contains beta-carotene. And that's true. Carrots do have beta-carotene. How about the converse? The converse would be that the conclusion implies the hypothesis. So if a vegetable contains beta-carotene, then it is a carrot. And that is actually false, because there are other vegetables that also contain beta-carotene. How about the inverse? Not P implies not Q. So if a vegetable is not a carrot, then it does not contain beta-carotene. That one's also false. We could cite the same counterexample here. Let's say tomato. Tomato has beta-carotene, but it's not a carrot. Same thing here. Tomato has beta-carotene, is not a carrot. Contrapositive. If a vegetable does not contain beta-carotene, then it is not a carrot. And this is true. If our vegetable doesn't have beta-carotene, and every carrot has beta-carotene in it, then our vegetable must not have been a carrot. So, take a look at this. I think there might be some debate as to the truth value of this statement, but if it's whether you think it's true or false, it ought to have the same truth value as its contrapositive, which is right here. And then here, the converse and inverse should also have the same truth value. Whether it's true or false depends on what you really think about this. Well, that's the end of the lesson. Go ahead and do the practice assignment and the formal write-up, and I'll talk to you on the computer. Bye.